Hello, Assalamualaikum. My name is Hakim AZMAN and my matrix number is B081810265. And today I'm going to explain about my final year project, condition monitoring of electrical motor based on vibration analysis data. So as for the introduction, electrical motor reliability and availability turn out to be important in industrial application. With the utilization of many types of electric motors in industry, induction motor is one of the high efficiency, robustness, and simplicity of construction. So condition monitoring is a regular observation and record of data in the report. This project is focusing on how to monitor the condition of electrical motor by using vibration analysis method. So my objective for this project to examine the vibration data using vibration analysis technique, to measure the vibration parameter of the induction motor, and the last one is to evaluate the condition of motor based on condition monitoring by using vibration analysis technique. My scope of project is focusing on correct method by applying vibration analysis technique. Second one is to examine three different conditions on electrical motor. The third one to identify the performance of electrical motor by using vibration analysis technique. And the last one is motor specification. For my research methodology, the flowchart starts with background study and then testing procedure, data collection, data analyze. If the data is valid, we'll go through the condition assessment. If not, we have to take the data again and then proceed with condition assessment. So for my methodology, I'm going to use a three-phase induction motor, a magnetic accelerometer sensor, vibration analyzer, and SO Smart Office Analyzer software. As for the three-phase induction motor, the specification of this motor is 370 watt, operating with 50 to 60 Hz. The magnetic accelerometer sensor will mount it on the part of the motor to take the vibration data, and it is connected to vibration analyzer, and the magnetic accelerometer sensor will act as a transducer. After that, from the vibration analyzer, it will connect it to the SO Smart Office Analyzer software to take the data. So for my project, I will focusing on three parts: bearing, stator, and housing. For each part, I will conduct with 5 different level of speed, which is 1600 rpm, 1800 rpm, 2000 rpm, 2200 rpm, and 2400 rpm. That's all for my research methodology. So this is my result analysis. Basically, the data from vibration analyzer, we will get frequency domain and time domain. But right now, I'm focusing on the frequency domain because it is easy to read the data. So based on the figure above, this is a comparison between three different conditions on frequency domain waveform. So the first one is at the no load. The second one will be at balanced load. And the third one is at unbalanced load. The data is reading is at bearing. As we can see, the highest peak of the amplitude is at the unbalanced load. The value show 0.0171. The data that obtained, I will refer to the ISO 10816/1 standard to evaluate the condition of the motor. For the conclusion, in this project, the use of vibration analysis to examine the vibration data gain, as the objective of this project was to analyze data from vibration. It is successfully achieved. During experiment, the electric motor were tested with 3 different conditions on it, which is no load, balanced load, and unbalanced load. The motor operates with no load, balanced load, and unbalanced load in order to make comparison that can be found through the time domain and frequency domain waveform. The increase of speed can change the amplitude of the vibration data. So this is my reference. That's all from me. Thank you.
Dua, tiga.
Okay, in my project, I will use 3 different conditions, which is no load, motor with no load, motor with balanced load, and motor with unbalanced load. So the first condition is motor with no load. So I'm gonna take the reading at bearing first. So this magnetic accelerometer, I will mount it near the bearing. And so before we run the motor, we need to set up the condition. So this one just set. Okay, I will use only one channel for the magnetic accelerometer sensor. Make it to respond channel and put it in m over s squared for the acceleration, and the sensitivity is 100, and this one is mv over eu. Okay, done. So the next one is for the source channel. We use channel 1, nothing to change here. So for the acquisition setting, I will use the sample rate is 512 Hz, and the block size is for 4096, and the time taken to take one reading is for 8 seconds. Okay, for the processing setting, I will record for time record and spectrum, and this nothing. Window type is Henning. Okay, so for the last step for setting is we must take the time record and the spectrum, and then okay. So the next step, I will start the motor before take the reading, and I will use 5 different speed, which is 1600, 1800, 2000, 2200, and 2400 RPM for the speed. So increase the speed until 1600. connected the magnetic accelerometer sensor. So we can see here. We just switch until we get the reading. See? Okay, so the measurement is, we can get here is spectrum for the reading, and time record for the reading at speed of 1600 rpm. So we will repeat this step until the 2400 rpm.